Good day, students. Welcome back to our mathematics class. Today's class, we are going to be talking about logarithms of numbers less than 1. If you can recall, we have discussed about standard form and as well as indices. Today, let's now dive into logarithm of numbers. But before we move on this, if you are a new member on this channel, kindly subscribe to my channel and click the notification bell for my subsequent contents. For our usual members, try to share, comment, and like. Let's move on. Example 1. Use table to find the logarithms of A 37, B 3.7, C 3,810. First of all, when we refer to table, what does it mean? We are referring to as the four-figure table, as it is generally called, or mathematical table. So this is mathematical table. They also call it statistical tables and formulae. We are going to be using this for table to find the logarithm of this. The first one, question A, we want to find the logarithm of 37. One thing we have to bear in mind is in looking for logarithm, to check the logarithm table of 37, this is 37. The first digit here is 3. You are going to cover this 3 as if this 3 is not existing, you cover it. We are still coming to use it. Then you count how many digits are at the back of this first digit. How many digits are at the back of the first digit? But you must not jump any decimal point. And when you are counting and you get to decimal point, you stop. Now, if I want to count here, how many digits are at the back of this 3? We have 1, just 1 digit. We call it 1 point. Fine. Let's check for the second one, B, 3.7. If I cover this 3, and I want to count how many digits is at the back of this 3, but I must not jump the decimal point. So if I cover this one, but I must not jump this point, definitely there's no digits at the back of the 3. So I call that one 0 points. Fine. For C, we have 3,810. If I cover this 3, and I want to count the number of digits at the back of this 3, I count 1, 2, 3. I have 3 points. Now, the next step is to now find the logarithm of these numbers. Now, let's check the logarithm. You are going to check 37. There's no digit at the back of this 37. We call it 0. 37 under 0. Opening to our mathematical table, we move on to logarithm of numbers. Logarithm of numbers, that is page 2. When you see this is page 2. If you look up here, we have logarithms of number. Then we want to check for 37 under 0. We have x here, x value here. Then we have 0, 1, 2, 3 to 9. Then we now have another one here, they call it differences. Those numbers here, they call it differences. We normally add those differences. Now I want to check for 37. You now come under this value of x, you trace down to 37. This is 37 here. That is 37. 37 under 0. We have 5, 6, 8, 2. So to check the logarithm of 37 under 0, it should be, this is 37 and this is 0. After locating your 37, then you locate your 0. So we have 5, 6, 8, 2. You can see 5, 6, 8, 2. So we write. 5, 6, 8, 2. Likewise, this one, 37. There's no number here. You check 37, but you will not check 3.7 because logarithm here always starts from 10. It starts from 10, no decimal points. So we are going to check 37 as in this one, under 0. The same value, 56, 5, 6, 8, 2. Now when we get to these points, what are we going to check? 38 under 1, difference 0. I repeat, 38 under 1, difference 0. So let's check our four-figure table again. Let us locate 38. This is 0, don't forget. X rather. You check. This is 38 under 1. This is 1 up here. You trace down to where you have 38. So this is your 38. Trace it to 1. What do we have? We have 5, 8, 0, 9. Can you see clearly? 5, 8, 0, 9. 5, 8, 0, 9. Now this is difference 0. When you check under these differences, you can see these differences written here. It starts from 1 to what? 9. So there's no difference 0. So nothing to add there. So this is how to check logarithm table. How to check logarithm table. Example 2. Use table to find the logarithms of A, 37.4, B, 3.746. The first one, 37.4. The second one, 3.746. Now, let's check for the first one. To check this one, you're going to check 37 under 4. 37 under 4. So let's look at this again. This is our x. We want to trace for 37. This is 37 here. 37 under 4. Then you count. This is 4 here. You trace your 4 down to where you have 37. So what do we have here? 5729. 5729. But before we write that 5729, as I said, you have to first of all cover these first digits. When you cover the first digit, you count the number of digits at the back of this first digit, but you must not jump the decimal point. If I cover these 3 and I count 1, so I cannot jump this point, definitely I'm going to have 1 point. I'm going to have 1 point. Now, 37 under 4, as we have checked before, is going to be 5729. 5729. Fine. Now, for this B, you are going to check again. 37 under 4 differences. But before then, if you cover the first digits and you count the number of digits at the back of the first digits, but you must not jump points. If I cover these digits, this is point. I can't jump the point. Definitely, there's no number at the back of it again. I call it 0 points. Then I will now check 37 under 4 differences. But 37 under 4, as you have checked here, it gives what? 1.5729. We need to now check difference 6. Now, as we said, this is our differences. 37 under 4. This is my 37 here. Under 4 is 5729. Then you now trace your difference 6. This is your 6. Trace it down to 37. So this is 37. This is difference 6. So the difference 6 here is what? Difference 6 here is 7. So which means I have to go and add 7 to it. Don't forget, addition will take place at the right hand side. 7. 9 plus 7 we have 16. 6 carry 1. 1 plus 2 we have 3. 75.1. So I'm going to have, this is 0 points. This is 0 points. So I'm going to have 0 points again. 5, 7, 3, 6. Now, This is how to check the logarithm of numbers. Now, in checking this logarithm of numbers, we now want to look at it very well. This 0 here, we call it integer, integer. While the remaining part here is called decimal fractions, decimal fractions. So if I ask, what is the integer of this value? It means that to get the integer of the value, you cover the first digit number and you start counting from the back of the first digit number without jumping the decimal point. So if I cover this one and I count 1, I can't jump this one. That is 1 point. Okay, come to this. If I cover this first digit number and I want to know the integer here, I count 1, 2, 3. That is called 3 points. So integer will have a number with a point, a digit with a point, 3 points, 1 point. And if you cover this one and what we have now is point, it means you cannot jump the point. That is called 0 point. That's our integer. So when you now check your logarithm, like checking 37 under 4 different C's, everything gives us 5736. This 5736 is called decimal fractions. So since we understood this one on how to check logarithm, let us now look at how do we check anti-logarithm. Example 3. In this example 3, as I said, we want to look at anti-logarithms. Anti-logarithms means the opposite, that is the reverse of logarithm. Example 3. Use table to find the anti-logarithms of the following. A. 0.5682. To find the anti-logarithm, we are going to look for the anti-logarithm of the decimal fractions. This is our logarithm here. You check the anti-logarithm table for 56 under its difference 2. Now we move on to anti-logarithm. If you check this, we have anti-logarithms of numbers here. You can see it starts with 0.00. You can see 0.00 and so on like that. 0.00 up there, 0.01, 0.02, and so on. Unlike logarithm that started with 10, but this one is 0 points. Now I want to now check the anti-logarithm of 56 under its difference 2. Now let us now check the anti-logarithm 56 under 8 difference 2. So that 0 points there will be neglected, meaning we are still coming to that. Now let us go and check 0.56. This is 0.50. Don't forget we are at anti-logarithm. 0.56. This is 0.56 under 8. You trace your 8. This is 8, which is 3698. 3698. Let's write it down. 3698. Then difference 2. Don't forget we are at 0.56 under 8. We have 3698. Difference 2. You can see a difference here. This is 2. The difference 2. What do we have here? We have 2. So we are going to add the 2 together. Plus 2. 8 plus 2 we have 10. 0 carry 1. 1 plus 9 we have 10. 0 carry 1. 1 plus 6 we have 7. Then we have 3. So which means that we are going to have 3700. Fine. If you could recall, under logarithm, when we are looking for logarithm, we did not count the first digit to check our integer. Under logarithm, we cover the first digit. That first digit we did not count will now be added to this 0 now. When you add 1 digit to this 0, 0 plus 1 give us what? 1. Then you shift your point from here. 1. So which means the anti-logarithm here is now 3.700 or 3.7. B, 0.5775. Now I want to check the anti-logarithm for this. Don't forget, we're going to check 0.57 under 7 difference 5. So let's check. 0.57 under 7. This is 0.57 here. You can see very clearly. 0.57 under 7. We have 3776. 3776. Then difference 5. Come and check under difference 5. These are difference here. These are 5 here. Check under 5. We're checking 0.57. Difference 5 is 4. Is 4. So you're going to add this 4. So 57 under 7. 3776. 3776 plus that difference. So that difference, the difference is 4 plus 4. Now we add 6 plus 4 is 10. 0 carry 1. 1 plus 7 we have 8. Then we have 7 and we have 3. So I'm going to have 3780. To now move our points, you add 1 to this 0 here. That's the first digit number we did not count under logarithm. We had it here making 1. Then you shift your points this way. So it means it's going to be 3.780. Let's change this one, this 0 here. Let's change it to 2. Okay? Let's change it to 2. Now I want to check 2.5768. Don't forget, we are checking for antilogarithms. Now we check 57, that 0.57 under 6. So this is 0.57 here. 0.57 under 6. We have 3767. 3767. 3767. Now, difference 8. You go and check your difference and we had. Difference 8.57. My difference 8 is 7. This thing is covering this. Okay. Difference 8. This is 8 here. You can see 8 here. So difference 8, we have 7. So we add 7 to it. Plus 7. 7 plus 7, we have 14. 4 carry 1. 1 plus 6, we have 7. Then 7, 3. So here, the antilog is 3774. To now locate our decimal points, you add 1 to this integer here. 1 plus 2, we have 3. You shift your point 3 times. 1, 2, 3. So we have 377.4. So this is how to check logarithms and antilogarithms. Now, we now move on to the multiplication and division of logarithm numbers. Now, we move on to multiplication and division using logarithms. Example 1, evaluate 34.83 times 5.427. So we're going to have number log. So we have 34.83 multiplied by 5.427. Now, as I said earlier on, the first thing to note is you find the integers. How do we get the integers? To get the integers of these values here, you cover these 3. The first digit here, you cover it. Then count the digits after this first digit. And you must not jump the decimal point. So if you count, this is the first digit, 1. And you cannot jump this point. So we say we have 1 point as our integer. Okay? For the next one, when you cover this first digit, you cannot jump this point. There's no digit at the back of it again. We call that one 0 points. The next thing is to now go and check your logarithm. Logarithm table, 34 under 8 difference 3. Now we check 34 under 8 difference 3. That is logarithm. Don't forget, you have to take it to logarithm. You make sure you are at logarithm. 34 under 8 difference 3. So this is your x to 34. So this is your 34 under 8. When you trace this 34, this is my under 8 here. You can see 8 at the top of it. 34 under is 5416. Difference 3. Our difference 3, trace it again to this 3. That is 4. 5416. So you add it up. Take your calculator or you add it up manually. 5416 plus this 4. So we're going to have 5420. 5420. 5420. Fine. Then this one, you check 54 under 2 difference 7. 54 under 2 difference 7. We are still checking logarithm. 54 under 2 difference 7. These are 54 here, down here. 54. These are our under 2. 7240. Difference 7. These are difference 7, 6. So when you add this 6 to 7240, we have 7246. 7246. 7246. If you can recall, in our indices, multiplication in indices will change to addition. So we have plus here. So we add 0 plus 6, we have 6. 2 plus 4, 6. 4 plus 2, 6. 5 plus 7, we are going to have 12. Here we are, write 2 carry 1. 1 plus 0 is 1. Plus the 1 you've carried, that is 2. Now, when you sum up your logarithm, we have 2.2666. The next thing is to find our final answer. Our final answer is by checking our anti-logarithm. Anti-logarithm. What are you going to check? You check 0.26 under 6 difference 6. I repeat, 0.26 under 6 difference 6. So we move on to the anti-logarithm part of it. This is the anti-logarithm. 0.26. These are 0.26 under 6. 1845 difference 6. So when we had 1845 with this difference, which is 3, difference 6, which is 3. So 1845 plus 3, we have 1848. 1848. 1848. Now, the next thing is to move our points, our decimal point. Before you move your decimal points, the one digit you did not count when you are determining your integer, you add 1 to this 2. 2 plus 1 give us 3. You move your point 3 times. 1, 2, 3. So we have 184.8. Example 5. Work out 4562 divided by 98.76. Don't forget, we are dealing with logarithm. So to work it out in terms of logarithm, so we have number log. So we have our values 4562 divided by 98.76. The first thing to determine is to get our integers. Don't forget, you cover the first digits and you count the digits after the first one. 1, 2, 3. We call it 3 points. Also, when you cover the first digit here, you count the digits after the first digit without jumping the decimal point. We have 1. That is called 1 point. Then, we check our logarithm table. 45 under 6 difference 2. 45 under 6. Don't forget, you are checking your logarithm. 45 under 6 difference 2. We have 45 here. Under 6, we have 6590. Difference 2, we have 2. 6590 plus this 2, we have 6592. 6592. 6592. Now, the next one is to check 98 under 7, difference 6. 98 under 7. This is 98 here. Under 7, we have 9943. 9943. Difference 6. Here we have 3. So when you add 9943, 98 under 7, 9943, with this difference 6, we have 9946. 9946. 9946. Now, here, this division here in our indices, we change to subtraction. So we subtract, so we have 2 minus 6 is impossible. You come to this 9 to borrow 1, this remains 8. Put the 1 here in the front here, making 12. 12 minus 6, we have 6. Then 8 minus 4, we have 4. 5 minus 9 is impossible. You come to this 6 to borrow 1, this remains 5. Put the 1 in front of this 5, making 15. 15 minus 9, we have 6. Then 5 minus 9, as we have here, come and borrow 1 from here, put it here, making 15. 15 minus 9, we have 6. Fine. This remains 2. 2 minus 1, we have what? 1. The next is to find our final answer by checking your antilogarithm, 0.66 under 4, difference 6. 0.66. So we have this 0.66 under 4. This is 4. 0.6 under 4, we have 4613. Difference 6 is 6. So 4613 plus this 6, when you sum it up, we have 4619. 4619. Now, to now determine our decimal points, you add 1 to this integer here, making 2. Then you shift twice. 1, 2. So we have 46.19. Example 6. Use table. Use table to calculate 2.413 times 3.092. So we have number log, as usual, 2.413 multiplied by 3.092. The next thing to do, as you know, is to find the integer. What is the integer of 2.413? Yes, it is 0 points. How do we get 0 points? You cover the first digit number and you start counting, but you must not jump decimal points. 0 points. And the second one as well, the integer is 0 points. The next step, you now go to your logarithm table to check 24 under 1, difference 3. We have 3825. Now this multiplication here changes to addition. I check 30 under 9, difference 2. We have 3903. So we had 5 plus 3, we have 8. 2 plus 0, we have 2. 8 plus 9, that is 17. 7 carry 1. 3 plus 3, that is 6 plus 1. 7 points. 0 plus 0, we have 0. The next thing is to go and check your antilogarithm. 0.77 under 2, difference 8. We have 5927. The last step is to now add 1 to this integer and move the decimal point 1 times. 1. So we have 5.927. 5.927. Example 7. Use table to work out 46.31 divided by 38.742. We have number log. We have 46.31 divided by 8.742. Now check logarithm, or before your logarithm, let's check for the integers. You cover the first digits and you start from the back of the first digits without jumping decimal point. We have 1. So we have 1 point. Likewise, this one, cover this one. If you cover this one, we have a decimal point and we cannot jump it. Definitely, there's no this after. We call it 0 point. Now, let us check logarithm. 46 under 3 difference 1. Don't forget, make sure you are checking logarithm, but there will always be a mistake. And that's why after this class, you have to do a lot of exercises in order to get used to this logarithm table. So let's check 46 under 3 difference 1. We have 6, 6, 5, 7. Now let's check 87 under 4 difference 2. We have 9, 4, 1, 6. So this division changes to subtraction. So we have 7 minus 6, that is 1. 5 minus 1, that is 4. 6 minus 4, that is 2. 6 minus 9, impossible. Come and put 1 from here, put it here, making 16. 16 minus 9, so we have 7. This has remained 0. 0 minus 0, we have 0. Then we check our antilogarithm. 0.72 under 4 difference 1. We have 5, 2, 9, 8. So when you add 1 to this 0 making 1, you shift your point once. 5.298. Now, we've come to the end of today's class. I'll be very happy if you can attempt these questions. Use table to work out the following. Number 1 to number 4. You can do it and send down your answer to the number shown on the screen. After doing it, snapshot it and send it to the number on the screen. I will respond to you by getting you the proper answer and correct the mistakes if available. I remain your tutor, Latif Ismaila Akombi. If you are a new member on this channel and you find this very helpful, kindly subscribe to my channel and click the notification bell. And don't forget to share to your loved one also. Thank you very much. Until we meet in the next class.